Okay, so let's start. Actually, welcome everybody. We have this panel on cybersecurity of smart electronics from IoT to vehicles, and myself, Himanshu Thapliyal. Just to give you a brief background about myself, I am assistant professor in University of Kentucky, and I work in the area of hardware-based cybersecurity and emerging technologies. So when we were discussing about this panel, actually, something that was of interest, actually, that recently there is a conference that Dr. Mohanty, Anirban, and we started on the area of smart electronic system, and then we thought, okay, that maybe it is a good idea to see that how the cybersecurity of the smart electronics can play a role broadly on the consumer electronic perspective. So just to define that, smart electronic systems are a class of intelligent and miniaturized devices that are highly energy efficient and ubiquitous. And they have applications in smart connected vehicles, smart grid, smart home, smart cities. So now you can see that from that perspective, then the era of IoT is here, and you can see from this figure that how the growth of IoT devices is moving on. So it is expected that by 2020, we will have around 50.1 million devices. And these devices are usually battery operated and small in size. And you can say that data is transmitted wirelessly. And this is one graph that you can see from here that projects that desired lifetime with the power budget. So you can see from this perspective that if your system is consuming huge amount of power, then your battery is going to be drained very quickly. So what does it lead to? It leads to that when you're designing these IoT systems, there is a constraint on energy efficiency and security. And these IoT devices are vulnerable to also to side channel attacks, such as power analysis-based attacks. Then there is also the issues of IP piracy, counterfeiting, Trojans, malware attack. So you can see from this perspective, it's a very, very difficult scenario now to deal with smart systems, because on the one side, you have the constraint on energy. On the other side, you have to provide the security. So it's a trade-off now. So if you see now from IoT, if you look into the era of connected vehicles, then you can see from this figure, there's a figure, and you can see here there is in-vehicle information system, gateways, then you have connected cars, this body electronics. So now you can see from that perspective that your vehicle is a complete electronic system. It has millions of lines of code and around 100 control units. So from that perspective, if you look into this figure, that is one of the hardware security module of the vehicle, and it consists of various encryption engines, for example, asymmetric and symmetric crypto engines. So from that perspective, the issue is that the attacker can also inject some malwares into your system by attacking your CAN bus. And also, the important perspective that I want to bring it to this to the audience today, that nowadays there is also a threat of quantum computing. And the reason you can see in this figure that there are a couple of asymmetric, specifically symmetric crypto engines, which can be vulnerable to quantum-based attacks, but that you can handle by increasing the key length. However, specifically, asymmetric crypto engines such as RSA and ECC can easily be broken down by quantum cryptanalysis. So the idea is that you have to bring post-quantum cryptography into picture, but again, there is an issue that how can you bring this post-quantum cryptography into IoT devices, because you have a constraint on energy, area, and along with the security. So with that, we assemble a group of panelists which will provide you expert perspective in that. And to start with, we have the panelists Dr. Saraju Mohanty, Dr. Arinbar Sen Gupta, and Dr. Sandeep Ray, who will provide you the perspective on this domain.